Hi, everyone. Just wanted to take a minute to talk about how to solve inequalities. Um, you'll notice when we go through these that solving inequalities is very similar to solving equations, but there's a couple little things that we do need to keep note of, and that are little intricacies that we need to be aware of and um, use correctly. So that's why I want to just go through a couple different examples. So again, all we're going to do in this case is we're going to do this the same way we would have solved an equation to start. So I'm going to start by distributing. That's just my personal choice on that one. So I get negative 4w minus 12 plus 7 is less than negative 29. Okay. I'll combine like terms. Minus 5, negative 29. All right, add the 5 to both sides. Negative 4w is less than negative 24 because negative 29 plus 5 is negative 24. All right, and now I am going to divide by negative 4. And for those of you that have seen inequalities before, or let me say, remember dealing with inequalities in the past, you'll notice I just divided both sides by a negative number. So when you are dividing um, both sides by a negative number or multiplying both sides by a negative number, you have to remember to flip the inequality. So you would get w is greater than 6. And the reason behind that is essentially because if I were to pick any number, let's say w equals 0, because if I didn't flip it, I would have gotten w is less than 6. And I plugged that in, I would have gotten negative 4 times 3, just because I'm plugging in 0 for w, plus 7 is less than negative 29. And I would have gotten negative 12 plus 7 is less than negative 29. And that means I would have gotten that negative 5 is less than negative 29. Now, clearly, that's not true. Because negative 29 is further from 0. And that's really kind of where the issue lies when we multiply or divide both sides by a negative, right? Because when we have the absolute value of negative 29 is bigger than the absolute value of 5, but when we're dealing with the negatives, it creates a situation where it's not true. So that's what we need to be careful of when we divide both sides by a negative or multiply both sides by a negative. And I'm making sure to say both sides there because here you saw I distributed the negative 4, but I didn't have to worry about that because it was all restricted to one side. Okay, so now I have my solution. However, it's different from what kind of solution I would have gotten with an equation, right? If I got an equation, I would have gotten something like w is equal to 2. Or w is equal to 6. And that is just one potential. That is it. That's the one thing I can plug in and make both sides of the equation the same. This is saying if I plug in any number bigger than 6, could it be 6.001, could be 72, could be 100 million. It will ultimately give me a scenario where my number on the left-hand side is less than negative 29, all right? So that is one of the big differences. We need to be careful because we're not just saying one number now, we're saying there's a whole set of numbers. There's actually infinitely many numbers I could plug in and make this inequality true. The one restriction is the number that I plug in has to be bigger than 6. All right, so how the heck do we represent all of that? Well, there's obviously this. This way is just saying w is bigger than 6. Okay, how else can we represent that? We can represent that with a graph. You may or may not have seen this before. So I'm going to make negative 1, 0, 1, 2, 3, 4, 5, 6. And I'm just going to tell you right now, this is the only time you're ever going to see me put this many numbers on a number line. I'm usually way lazier. It'll do like 3 numbers and move on. All right, so I'm saying that w is greater than 6. So there's a couple ways I can denote that on a number line. The most common way you've probably seen would be with a circle at 6. So I look at my number here and I go to 6 and I put it a circle. I put an open circle because it is strictly greater than. And the reason behind that is because I can't include 6. If I plugged 6 in, I would get negative 29 is less than negative 29, which is not the case, right? Negative 29 is not less than 29. Negative 29 is equal to negative 29. All right, so then what you do is you would just go off to the right because it's bigger, right? So any number over on that side of the number line is going to make this inequality true. Another way you could do this would be if you put a parenthesis instead of an open circle and gone to the right. That's just another way of denoting the open circle with a parenthesis. And if you had a closed circle, it would be with a bracket. That one's a little less common, but I've seen it in our book a couple of times. So I just wanted to let you know about that one. Okay, and then another way you could denote this would be something called set builder notation. And basically what we're doing is this is our notation where we just build a set. Because my solution is a set, right? It's a set of numbers such that W is bigger than 6. So it's just some number W, okay? And such that, this line just means such that. Because mathematicians are too lazy to write words. Remember that, everyone. Mathematicians are like the laziest people on the planet. If they can get away without writing a word, oh, they would love it. All right, anyway, so the set of numbers W such that W is greater than 6. So I have seen our book use that as set builder notation. And then the last one, and this one's my kind of personal favorite, is interval. I actually haven't really seen our book use this, but they seem to use the notation that like closely relates to it without actually using it. So interval notation is just saying I can't spell. Is saying I have a number W that is an element of, and the element of symbol is basically like a little small, it's like an uppercase E, but it's curved. The set of 6 to infinity. Okay. So I like this one just because we have the parentheses here, and our book does like to use the parentheses on the number line. So you could remember if it's less than or greater than, we have the parentheses. If it's greater than or equal to or less than or equal to, we'll have the bracket. You're never going to put a bracket with the infinity symbol, or in the case of it going the other direction, the negative infinity symbol. And the reason behind that is because infinity is a concept, not a number, right? We keep going on and on and on and on forever. So infinity is a concept, not a number. All right. So now that we have kind of looked at different ways we could express that, let's look at this next one. So again, I'm just going to distribute 2x minus 6 minus 3x greater than or equal to negative 1. Add, we'll simplify negative x, is right, 2x minus 3x, negative x, minus 6 is greater than or equal to negative 1. I will add 6 to both sides. Add 6 to both sides. Negative x is greater than or equal to 5. And then again, I'm going to divide by a negative on both sides. So I do have to remember to flip the inequality. Negative 5. So I have x is less than or equal to negative 5. So how can we denote that? All right. So again, we can use our trusty number line here. And I already told you I'm going to be super lazy with these number lines. So 5, we're counting by 5s on this one. Negative 5. Okay, we are less than negative 5. We are now less than or equal to, so we do have to use a closed circle. Or again, if you weren't using a circle, you could use a bracket. Same difference. And now we're going that direction, right? because it is less than. Numbers that are less than -5 are more to the left, right? Less than to the left, greater than to the right, less, left, LL. All right, anyway. Set builder would be essentially the same thing. That's a horrible bracket, but you get the point. X such that X is less than or equal to -5. Now, essentially, in this case, right, when we have less than or equal to, the biggest number I could have would be 5. So now if I'm using the interval notation, I'm not starting with the -5. I'm starting with everything to the left of -5. And what's everything to the left of -5? Just infinitely more negative numbers, right? We just keep going infinitely many negative numbers that way. So the way I would express that is we're still using X as an element of. However, now I'm continuously going less. So I'm going less forever. So that is something we denote by negative infinity. And then finally, we're going all the way up to -5. And we actually, in this case, did include the less than or equal to, so we do have to include -5. So we have negative infinity to -5 and then the bracket. So again, that's why, I kind of like the interval with the bracket notation on the graph. Just it kind of lines up nicely. So just as a heads up on that one. All right, last one, and then that'll be it for this. So let's look at solving that inequality. And this one's a little bit different because now we have X on both sides. And similar to having X on both sides of an equation, we could end up with scenarios where the X's cancel out, or we could end up in a scenario like the other two above, right? Where we would just get this one kind of set situation. So now instead of having, infinitely many solutions, one solution, 0 solutions, we still have no solutions. That is still a possibility. When they cancel out and you get something like 5 is greater than 10, right? If you got something like 5 is greater than 10, that's just never true. 5 is never greater than 10. It's just not. So if we end up in that scenario, I have no solutions. If I end up in a scenario where I got something like 5 is greater than 0, well, that's always true. So I would have any number. I could plug any number into that inequality and it will always be true. All right. And then finally, you could end up in a scenario just like up here where you have a cutoff point of, say like 5. If it's greater than 5, it's true. If it's less than 5, it's not true. Something like that. So there are still the different scenarios you can end up with. In this particular problem, let me just write it over here. When I distribute, I get 4x plus 6 is less than 4x minus 4. I'm going to subtract the 4x from both sides. Subtract the 4x from both sides. And I will get that 6 is less than -4. So as I said, this is one of the potential solution set cases that I just talked about. In this case, we got 6 is less than -4, which it's not. So no matter what number I plug in here, it's never going to work. I could plug in 0, I could plug in 100, I could plug in -17 billion. It's not going to work. So how do we denote that? Well, obviously, if we drew a number line, there'd be nothing on it. If we did an interval, there'd be nothing. So if you ever see anything like this, one of the notation, they would either say there is no solution. That is a possibility. You could also see something along the lines of this. And it's an element of this, which is the empty set, which is basically saying it's a set of nothing. So if you ever see what is essentially a 0 with a slash through it, that just means the empty set. And that would be a way of denoting this, right? There's no solutions in my set. There's nothing. There's nothing in my set. Nothing in my set will work because there's nothing. If you had ended up in the scenario where there's infinitely many solutions, you could either just shade the whole number line. You could say that there's infinitely many solutions, every real number. The way you could write it if it was every real number would be, so if I ended up with a scenario like -4 is less than 6, you could write it something like this: x such that x is an element of, the real numbers. This is another way you can write that. That's just basically saying all real numbers. It's just a fancy math way to do it. It just means all real numbers. That's all it is, I swear. And then the other thing you could do would just say that x is an element of -infinity to infinity. Now, so these are the scenarios if you get like something like this. If you get something over here, there's no solution. You could use the empty set. You could just say there's no solution, either or. All right, I hope this answers any questions you might have, and probably more than you ever realized you wanted about inequalities. Please let me know if you have any questions. Have a great day.